In this video, we get into standard number 7. This is a final standard of the semester, and you won't be assessed on this till the final exam period. So, I have these two equations, and yeah, we are graphing. I have y equals negative 3 times x plus 2, and then there's a second equation that says y equals 2 times x, and then minus 3. Now, so basically what they give us is two equations, and each equation contains two variables, x and y. Now, whenever this happens, there's a way to find what each variable equals. And what I do is I set up the solution, what each variable equals, as a coordinate point. And I say, okay, so what do I do now? Well, what we're going to do is get each equation on a graph so I can see the solution set for both lines at the same time. And that's why I'm going to graph them both on the same plane. And then there's going to be hopefully one solution, just one point that's on both my lines. So I have that y and x on opposite sides, so that's in slope-intercept form. So I'm going to graph that with slope and y-intercept. And this equation here, this second one, that's also in slope-intercept. So I can graph that in slope y-intercept. Okay. So my slope here would be negative 3 over 1, since that's an integer, and the y-intercept would be 2, 0, 2. Remember, graphing the line is just a way to see the set of all solutions for x and y. So 0, 2, I go up 2. And then from the y-intercept, I go down 3 units and right 1 unit. And down 3, right 1. Makes the graphing process go quicker. Now, the line needs to be straight, so you'll need to take your straight edge and graph the line. Now, make your line kind of long so it spans the whole graph. Okay, so that's y equals negative 3 times x plus 2. That represents the solution set. Now, in the second coordinate, the second line, we have 2. It'd be 2 over 1, and the y-intercept would be negative 3. So negative 3, 0, comma. Okay, so I go down 3, 1, 2, 3. And then from there I go up 2 and right 1. So up 2, right 1, there's already a point, up 2, right 1. So then we graph the two lines. And again, a line represents all the set of all solutions for x and y. So there's one point that is on both lines. Well, it's where they cross at, okay? And that's a coordinate point because you're on the x-axis and the y-axis at the same time. So I'm at 1 to the right, so x is 1, and then y is negative 1. Okay, and that's our answer. And you can always test it out by putting 1 in. Negative 3 times 1 is negative 3. And adding 2 is going to give you negative 1. So likewise, 2 times 1 is 2. Take away 3 is negative 1 as well. So that's the one solution that works, that is on both lines. Okay, now we have x minus y equals 5. 3x plus y equals 3. Now these are both in standard form, okay? Because the x and the y are on the same side together. So with standard form, what we're going to want to do is make our tables. We're actually going to make 2 of them because we need to graph 2 lines. Okay, so let's look at my first line. So x, by the way, I don't like minuses in front of variables. We're going to put a 1 there. And when I write this out twice, it's going to be x plus negative 1y equals 5. You can put a 1 in front of the x. And then 1x plus negative 1y equals 5. Okay, this equation here, I'm not worried about this one until I get down here. So x is 0, so we can eliminate 1x there, and if y is 0, we can eliminate the 1y term there. Then here I'm going to divide by negative 1. If I divide by what negative 1 is negative 5, so the y-intercept for this line on top is negative 5. Now, you can divide by 1. What's the point? Okay, it's still 5. Okay, so that's my y-intercept and my x-intercept. So I'm down 1, 2, 3, 4, 5. That's where 0, negative 5's at. Then 5, 0, I'm right 1, 2, 3, 4, 5. Okay, so I take my straight edge and just graph the line that runs through those 2 points. There's many points on this line. I just made 2 of them. Okay. And then the other line's standard form, so let's write that out twice. 3x plus y, if that drives you nuts not having a number there, put a 1 equals 3, and 3x plus 1y equals 3. So if x is 0, 3x can go bye-bye. And here if y is 0, 1y can go bye-bye. Okay, you can divide by 1, but it's still just 3. So the y-intercept's 3. And then we're going to divide both sides of my equation by 3 here. 3 divided by 3 is 1. Okay, so x is 0, y is 3. So I go up 1, 2, 3. And then 1, 0. I just go right 1. Okay, then I make the line that goes through those 2 points. And that shows all the solutions for that line. Okay, now you make your coordinate point, x, y, and you see where the lines cross. The crossing point's right here. Well, that means that point's on both lines. So we're at 1, positive 2 for x. So x has a value of 2, and y has a value of -1, -2, -3. So 2, -3 is my solution for that system. It's called a system. Whenever you have 2 equations, 2 variables, that's what that's known as. Okay, third example. The y and the x are on opposite sides, so that means it's in slope-intercept form. And this one, too, is in slope-intercept form. Might not look like it is, but it is. So I'm going to identify the slope and the y-intercept to graph both lines. This is why we learn. This primarily is why we learn this, so I can get the lines down very quickly. So the slope, that's m and b. So slope's 5, it'd be 5 over 1, and then 0, positive 2 is the y-intercept. Okay, so I go up 2, then I go up 5 and right 2. 1, 2, 3, 4, 5, right 2. You can't really do it again. That's okay. Okay. A line can go through 2 points just as easily as it can go through 3. So I make my line. Okay, now the other one, the slope would be 3 over 1, and the y-intercept would just simply be the origin, okay, 0, 0. Okay, so I go up 3, right 1, 1, 2, 3, right 1, 1, 2, 3, right 1. And the lines are kind of close to each other, but they do cross. Or will they? Yeah, let's not do that problem. I'm not sure. They would cross, you're just not able to see it on the graph. Okay, so we're not going to do that one. Okay, my next one, just put abort mission. Okay. All right, my next one. Now we have one of each. This is in slope-intercept. But this one here, the x and the y are together, so they're in standard. Okay, so we're going to do a slope y-intercept to get the first line graphed. And then in the second line, we're going to make our x-y-intercept table. Okay. So this line here, we got 2 over 1, and -1's the y-intercept. So I'm going to go down 1. Then I go up 2, right 1, up 2, right 1. And again, make the graph go through those 3 points. Okay, then 0, 0, we're going to write that equation out twice. -6 times x plus 3 times y equals -3, and then I'm going to write it again. So if x is 0, we can eliminate this -6x, and if y is 0, we can eliminate the 3y. So we're going to undo the multiplying of 3 by dividing by 3, and then y equals negative 3 divided by 3, which is negative 1 for my y-intercept. And here the answer is not 2. If you write 2 down, that's wrong. X is being multiplied by negative 6, so I unmultiply it from my variable by dividing by negative 6. Okay, if you have $3 divided amongst 6 people, I don't think everybody gets $2. Okay, everybody would get 50 cents. So that's 0.5 positive. Okay, so that's just going to be at a half on the x-axis. Okay, and then 0, negative 1. Well, we got a little interesting thing here. The fact that it's the same line. So if the lines are the same, that means there are infinitely many solutions. That's how you write. You can abbreviate that answer by writing IMS, infinitely many solutions. Again, I'll repeat that because I had this line down, but I find quickly that 0, negative 1, okay, I already have a point there, and 0.50, I already have a point there, so they're the same line, okay, and that means IMS, infinitely many solutions. Okay, next one. So this is in standard, and this is in standard, both of them. Okay, so they're both in standard form, so we're going to make two tables where I find the y-intercept and the x-intercept. Okay, so the first one we have negative 2x plus y. If you want to put a 1 in front of y, that's fine, so you have something there. Then I write the same identical equation. So x being 0, that means we can eliminate negative 2x. Divide by 1, it's still going to be negative 8. Okay, now if y is 0, we eliminate the 1y, and then we divide each side of the equation by negative 2. Negative 8 divided by negative 2 is 4. Okay, so 0, negative 8, I go down 1, 2, 3, 4, 5, 6, 7, 8, and that's your y-intercept. Then 4, 0, I go 1, 2, 3, 4, and that's my x-intercept. So I connect the points and have the line. By the way, we're not going to do anything on the bottom graph. There's only one problem. They need to be on the same plane so I know where they cross. Okay, now in the second one, that's in standard again, so we write the 2x plus negative 2y equals 8. And then 2x plus negative 2y equals 8. So x is 0 and y is 0, so we can eliminate those. Here we're going to divide by negative 2. That's why it's important to make that a plus negative. So we divide 8 by negative 2. That's negative 4. Then divide by positive 2. 8 divided by positive 2 is positive 4. So 0, negative 4, so down 1, 2, 3, 4. Then I go to 4, 0, so 1, 2, 3, 4. There's already a point there. That's okay. Okay, so I'm going to make my line through those 2 points. Okay, now there is a point that's on both lines. It's the intersection point. So I find what point that is. And that's at positive 1, positive 2, positive 3, positive 4 on the x-axis. And then on the y-axis, it's still at 0. So 4, 0 is the solution to that system. That's the one solution that works for each equation. Okay, and then my last one I'm going to go over. The y and the x are on opposite sides here. Okay, so that they're both in slope-intercept form, slope-int, slope-int. Okay, so remember, to have a slope, we'd put a 1 there. And then the y should not have any operations with it. So slope, y-intercept, MB. Then the other one is slope, y-intercept. That's MB. Okay, so negative 1 is your slope, negative 1 over 1, and the y-intercept would be 0 with positive 4. So I go 0, 4, 1, 2, 3, 4. I go down 1, right 1, down 1, right 1. You keep doing that, but 3 points kind of gets the point across. No pun intended. Okay, then in my other one, I have my slope of 2, so 2 over 1, and -8's my y-intercept. So I go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Then from there I go up to rise 2, run 1. So rise 2, run 1, rise 2, run 1. You could probably keep doing that for a while there. And they cross. Look like they cross in about the same place as the last problem. Okay, I make the point where they cross. Now, if your point is not smack on the grid, that's okay. Just put estimate what it's close to, okay? I mean, I tried to put ones that only had integer solutions, but sometimes you get the line a little bit off, okay? Just kind of estimate where they cross. So that's at 1, 2, 3, 4 again. X is 4. And y is 0. Okay, that's where I'm going to look to see the answer. Now, a few tips for you as you go to work these. Both these are in slope-intercept form. -1 and 1 are the slopes. 2 and -1, those are both in slope-intercept form. Now, on the back, you get them both in standard form. Now, if they're both in standard form, you're going to want 1s in front of that, and that's a -1. And likewise on this. And 1's here and there, because those are in standard form, okay? Then you'll be a much happier person because you'll know what you're doing.